Welcome to another lecture on engineering mechanics. Today we will cover two topics, couple and free body diagram. So let us start the lecture. Let us first see what is a couple. A couple consists of two equal, parallel, opposite and non-collinear forces whose resultant force is zero but has moment. The external effect of a couple is one of pure rotation. So let us understand this through an example. Suppose we have a body, and on that body, let us say two forces are acting. These two forces have equal magnitude and these are parallel, but these are opposite forces. And these are non-collinear forces. Their line of action is not same. So the resultant of these two forces will be zero, because if we are taking this force as positive because it is acting towards right direction, then we have to take this force negative because it is acting in left direction, that is the opposite direction. So if we will add these two magnitudes, it will be equal to 0. And we know that couple produces a pure rotation on the body. One more important point we can understand over here is regarding the moment developed by the couple. We know the formula of moment of a force is equal to the product of magnitude of the force and the moment arm. So if we have to find the moment of a couple, then we have to first locate the moment arm. So in case of couple, the moment arm is the perpendicular distance between the line of action of the two forces. So over here it is labeled as D. So if we have to find the moment of this couple, it will be equal to product of the magnitude of the force and the moment arm. Let us see few examples of couple. The first example is related to steering wheel of the car. When driving, your hands are opposite to each other on the steering wheel as shown in this figure. The forces you apply with both hands when turning either left or right cause it to turn. Both hands are involved in turning the wheel. One hand pushes while other hand pulls. The second example is related to cyclist. When a cyclist pedals, his or her feet are parallel. You can see in this example, feet are shown and these are parallel to each other. One foot pushes a pedal in forward while other pushes the other pedal backward. These two forces cause the wheels on the bike to rotate. So we have seen two daily life examples for couple. Next we will talk about free body diagram. Problems in mechanics of bodies involves the evaluation of a number of forces. This we all know. For this, the body acted upon by external forces and the reactive forces provided by the constraints is isolated, and the total forces, that is including the active and reactive forces, are marked on it. It helps to prepare a mathematical model of the physical situation. So we can define free body diagram as when the isolated body is drawn with all the forces and reactive forces acting on it, such a diagram is called a free body diagram. So over here one example is shown. This is the question given to us. You can see it is related to a crane which is spotted at two ends, at end A and at end B, and crane is lifting some weight. Now, if we have to draw the free body diagram of this particular situation, then in that diagram, we have to represent the bodies involved and all the reactive and active forces. Now you can see over here its free body is drawn. You can see two active forces are shown. One is the weight lifted by the crane. Second is the weight of the crane itself. Then we have labeled three reactive forces provided by these supports placed at end A and at end B of the crane. After placing active and reactive forces, we have placed different measurements also in the free body diagram. Now let us see what we include in a free body diagram. So let us take the same example to understand what we include in a free body diagram. First, we take isolated body. So isolated body over here is a crane. Then external forces by other bodies. In that example, we have seen that crane is lifting a mass of 2400 kilogram. So when we will convert this into force, that will become an external force. Then reactive forces from constraints. So in that diagram, we have seen that at end A, there is hinge support and at end B, there is a rocker support. So these supports will provide some reactions on the application of this particular force. So we have to show those reactions as well. Next is weight of the free body. So we will label the weight of the isolated body as well. And the magnitude and direction of the known external forces should be clearly marked. We have to mark the direction of all the forces and we have to show their magnitude as well. And after that we place all the important dimensions which helps us in order to solve the problem. So this is what we include in a free body diagram. So I hope you have learned about couple and free body diagram. Thank you very much.